Well, hi there, sports fans, and welcome to another exciting edition of Physics 12. Today we're looking at lesson 1.9, which is on projectiles. So this indeed is for you sports fans because anything that you throw or kick or hit with a bat or hit with some kind of a racket, it becomes a projectile. And so we're going to be looking at the motion of that today and how to analyze the motion of a projectile. Now, projectiles involve motion in two dimensions, the x and y direction, and so we need to analyze the motion in both of those in order to understand the motion of a projectile. Now, the most important thing to understand immediately about projectiles is that we analyze the motion in the x and y directions independently. So the motion in these two directions are kept separate. And if you can separate them in your mind, think about what's happening in the x direction independently of what's happening in the y direction. That will really help you in understanding and analyzing motion of a projectile, because they really are separate. So what we can say is, it could be said that what happens in the x direction stays in the x direction, and what happens in the y direction stays in the y direction. So we keep them completely separate. So we analyze the x direction on its own, we analyze the y direction on its own. Now together the two of them define the trajectory of a projectile, but when you're doing your analysis, keep them separate in your analysis, and try to keep them separate in your mind as well. And that'll help you understand what it is that's happening throughout the trajectory of a projectile. So here's an example of a projectile. This is a ball that's been launched, and it's bounced a couple of times here. And as you can see, the motion is quite rightly described as a parabola. And indeed, this is the motion of a parabola, and the equation of its motion would be the equation that you would recognize as parabolic in nature. And so you probably come across this in math already. Equations of parabola and the trajectory of these objects, of projectiles, you would recognize that as an equation for a parabola, and that is indeed what it is. So what we need to do then is, in analyzing projectiles, we need to look at the x component and we need to look at the y components, and we need to look at them separately, because what's happened here is when something is launched and it's given a velocity component in the x direction, that velocity component will always be the same. There is no acceleration with a projectile in the x direction. If it has an initial velocity when it's launched, that velocity will remain the same throughout its trajectory. Not so in the y direction, of course, because the object is being accelerated in the y direction by gravity. And so you might actually look at the trajectory of this and incorrectly assume, well, it looks like what's happening is that it's slowing down in the x direction. So as the further it goes out, it seems that it's slowing down in the x direction, but really it's not. The velocity component in the x direction is staying the same. What's happening is that it's speeding up in the y direction. So it appears as though it's slowing down in the x direction, but really all that's happening is the component of velocity in the y direction is getting larger and larger as time goes by. And so once again, there is no acceleration in the x direction. Nothing is accelerating. It's not speeding up, it's not slowing down. However, in the y direction, gravity is accelerating the object, so it is indeed speeding up in the y direction. And this illustrates it nicely here, because what they've done here is they've launched two balls, a red one and a yellow one, at exactly the same time. And one is given an x component of velocity, and the other one is just simply dropped straight down. And you can see that at the red and yellow balls are at the same height at each of the images. And so what that's illustrating is that in the y direction, the objects are always in the same place. They will always be at the same height at any given time. What's different about these two is, the only difference is that the yellow one has been given a component of velocity in the x direction, and the one in the red one does not. That's the only difference between these two. So you can see their motion in the y direction is identical in the y direction, not so in the x direction, however. So we can look at the velocity, vectors of the projectile throughout its trajectory. And as you can see, the velocity vectors will change over time. So if it's launched with a certain velocity in this direction, like here, it has an x component to it. That x component of the velocity, again, will be the same no matter where it is in its trajectory. The y velocity, however, will change. So the initial y velocity will continue to decrease, and at the top of its trajectory, that y velocity will indeed be 0 at that point. So its velocity vector at that point, at the top of its motion, will be identical to its x component when it was launched. The other interesting thing to note about this, and again we're ignoring air resistance and anything else, but when the object gets to the other end of its trajectory, like so, its velocity magnitude will be the same as when it was launched. So the velocity here will be the same at launch. The only difference is it will be in the opposite direction. However, that is some good information to know when you are analyzing these things, is that the velocity over here, the magnitude of that, will be the same as this one here. And the other useful piece of information is that at the top of its trajectory, the velocity in the y direction is indeed 0. And that's some useful information when you're going to analyze some of these problems. So problem solving then, involving projectile motion. And a couple of things to note about that is that it's motion with constant acceleration. It is in 2 dimensions, where the acceleration is g, which is 9.8 meters per second squared, and it's only in the y direction. So generally speaking, what we do is y is positive in the upward direction, the acceleration in the x direction is 0, and the acceleration in the y direction is minus g, which is minus 9.8 meters per second squared. And a couple of other things to note, the velocity in the x direction is constant, and they use a lot of other symbols in here, which you don't need to worry about too much. The important thing about this is that we want to be consistent in the use of direction, and so it's probably best if we just stay consistent using positive, up would be positive in the y direction, down would be negative in the y direction, positive in the x direction would be to the right, and negative in the x direction would be to the left. So if we just remain consistent with that, then it just makes it easier for when you're looking at somebody else's work. So problem solving with projectile motion. First of all, you need to read the problem very carefully and know exactly what it is that it's asking. Have you heard this before? Draw a diagram. This is important not only with projectile motion, but in any kind of problem solving we're doing. You've got to have a diagram and include the motion of the object on the diagram as well. That is absolutely going to be critical. I will be harping on that all the time. So save me the trouble of continuing to have to tell you that. Just go ahead and draw a diagram right from the beginning. Then choose an origin and a coordinate system, and then decide on time intervals. And then again, examine the X and Y motions separately. Keep them separate and start thinking about the differences in the X and Y directions, and keep them separate in your mind, and that will be very helpful as well. So then you list your known and unknown quantities. Remember some of the useful bits of information. The velocity in the X direction is always the same, and the velocity in the Y direction at the top of its trajectory or at the highest point is 0. And the velocity at the launch and the velocity at impact will be the same as long as they're at the same height. And then plan how you proceed. You'll check out your equations, see what information you have, and see what information that you need to find out, and then choose your equations that will help get you there. And you can see here's some examples of projectile motion, and indeed, when you look at them, you see that they are indeed parabolas. And so when you put the X and Y motion together, your equation will be something like that, which is indeed the equation of a parabola. And so you've probably come across those kinds of equations before, and parabolic motion, and that is indeed what we are dealing with when it comes to projectiles. So what you've learned about parabolas, that will come in handy when we look at projectiles, and that indeed the equations that we deal with are parabolas. And then the last thing, again, keep in mind that when we look at the X direction, keep that separate from the Y direction, and that will be very helpful in terms of dealing with these kinds of problems.